Hey there, grade 6. New video, new unit for you guys today. We're going to start in a couple of lessons on in the geometry section. And so we're going to just kind of do three. And the first one's called translations. And so your learning target for today is to perform translations on a grid. So a few skills that you need to know how to do. One of them is to perform and identify translations on a grid. Seems to kind of go without saying. The second thing is that you can measure sides and angles of polygons. Polygons are two-dimensional shapes, at least three sides. They're all straight and they're all touching the sides. All the sides are touching. They're triangles, squares, etc. Third skill is that you can identify congruent shapes. Congruent just means that they are identical in shape and size. So let's get started. Here it says that these two shapes are identical. In math, we say that they are congruent. Another word for congruent is clone. It's because, as I said, they are identical in size and shape. Now, if I want to move the shapes so that they line up exactly one on top of the other, facing the same direction, you can see I have two sort of arrow shapes. They are identical. You want to try to move them somehow, so you're like turning them or sliding them around a little bit. To sort of fit them on top of each other. And so there's a few things you can go through to do that. So what they say is to pretend that the shapes are very heavy, very hot sheets of metal. So to program a robot to move them, we need to divide the process into some simple steps. And these are sort of, over the next three videos, these are the steps that we're going to talk about. So you would use a combination of these three movements. You would slide it along straight lines, either horizontally or vertically. That's called a translation. You could flip the shape vertically, or you could flip it horizontally. That's called a reflection. Or you could turn it around a fixed point. You can sort of rotate. That's called a rotation. Okay? So these changes, translations, reflections, and rotations, they're all called transformations, which is kind of what this geometry unit sort of focuses on. And so just some stuff here in our diagrams, we'll sometimes see points like point A, and then you'll see something that looks like this, A with a little apostrophe beside it. We call that A prime. That little symbol in this case means prime. Or sometimes you use a star. Now often what I've seen in books is that you go from the original shape, say a translation or reflection or rotation, to get the prime piece, and then you could reflect or rotate or translate again to get a second translation or rotation or prime. So then you would use the star shape secondly. So you have A prime and then B to B prime or something like that. Okay. But for our video today, what we're going to do is focus on translations. And so what a translation is just sliding a dot or a point or a shape around. Okay. And so here there are 2 points. You could say, well, if I want to move it, one to the right and one down, that's where my point would end up. And so what I'm going to do is I'll go to the next slide and get some practice, and then I'll go back to the graph slide. So it says to draw a point on a grid and label it, draw point A prime, that is the image of A under the given translation. All that means is you have an original point, you move the point to get a new one, and then you get point A prime. Okay, so if we're going to be going 2 units up, if this is our original A, and we want to take it and move 2 units up, so it goes up 1, 2. Okay, then this becomes A prime. Okay, so that would be the first one. The next one said 3 units down. So I would take this point A and I would move it 1, 2, 3 units down, and then my A prime would be down here. Okay, I could move it 5 units to the right. So again, start here, 1, 2, 3, 4, 5 to the right, and so my A prime goes over here. Or I could have 1 unit left. So start here, 1 unit left, and then that becomes my A prime. You can also combine translations. You don't just have to do it, horizontally or vertically, you can do a combination. So you could say translate this counter 3 to the right and 2 down. So it would go 1, 2, 3, 1, 2. And so you're only allowed to sort of move them on a vertical or horizontal lines, but it looks like it's been moved diagonally, even though it hasn't. So then we're going to do some similar things, right? So we have point A and then A prime would be the translation. So we're going to start 2 units left, 1 unit down. Okay, so we go 2 units left, 1 unit down. This is our A point, and this is our A prime point. Okay, the next one says 4 units right, 3 units up. So we go 1, 2, 3, 4 units right, and then 1, 2, I think it said 3 units up. So that's where A prime would end up, 4 right, 3 up. And the last one, 6 right, 2 down. So that would go 1, 2, 3, 4, 5, 6, 1, 2. And so after that translation, that's where our point would end up. Just again, notice I'm just moving along the grid, either vertically or horizontally. Okay, we did that stuff. All right, so then to describe a translation, you need to say how much the point moved and in which direction. So for this one, here's point A and here's A prime. The red line talks about how far it went to the right. The green line talks about how far it went up. So we say it has gone 1, 2, 3, 4 units right, 2 units up. And that's how we would describe that translation. Now, we're moving on here from points over to full shapes. You'll notice that shape 1 and shape 2, they are congruent. They're identical in shape and size. And the question here says, how far did the rectangle slide to the right from position 1 to position 2? Sometimes we would be tempted to say, well, there are 2 spaces between here, and so it's moved 2 spaces. But let's consider this. Can we make it easier to see that the translation is 4 points to the right if we have this dot here and say, on the new shape, the dot is over here, so it's gone 1, 2, let's use a little drawing tool. And so it's gone 1, 2, 3, 4 spots to the right. Okay, so here's a couple of just quick exercises. It says which vertex, 1, 2, 3, or 4, is the image of the vertex marked with a dot under the translation. It's a fancy pants way of saying, okay, so here's our dot. Which of the 4 vertices matches up with the dot? And in this case, it's number 3. So that means it's gone 1 to the right, and then 1, 2, 3 points down. This one, our dot's up in the top corner here, and so it matches up with point 2, so it's gone 1, 2 to the right, and 1, 2, 3 units down. This last one here, here's the dot, and it matches up with vertex 4, so it means it's gone 1, 2, 3, 4, 5 to the left, and up 1, 2. So these whole shapes have been translated over, in that last case, 5 to the left and 2 up. Now, what it says is that under translations, all points on a shape move the same amount and in the same direction. Okay, so we're not, if we don't move them all in the same amount, in the same direction, what's going to happen is that they will get bigger and bigger, so you actually like expand or dilate the size. We don't want to do that. We just want to move the whole shape along the grid. So this one says 4 units to the right and 2 units down. Okay, so that means that point D, or we'll say point A, is going 1, 2, 3, 4 to the right, and then 1, 2 units down. And so I'm just going to use my click and drag rectangle tool. I made that a little bit bigger than I needed to. So that means that over here, that this is A prime. Okay, so we've gone 1, 2, 3, 4 to the right, and 1, 2 down. Pardon my messy shape here, but we've done the translation properly. Okay. Now the last few slides focus on congruent polygons and how it works with translations. So just try and follow me along with this one. So the question is, do translations take polygons to congruent polygons? So then the idea says here, if polygon A is an image of polygon B under a translation, then polygons A and B are congruent. So all that means is if you have polygon B would be your original, and then you've translated it to polygon A, and they are, you've done a translation, then A and B have to be congruent. The question here says, do you think it works the other way around? If polygons A and B are congruent, then polygon A is the image of polygon B under a translation. So here's an example where that's not true. Here we have two polygons, two rectangles that are congruent, but we cannot say here that one is a translation of the other. There's no way, if this is, if you imagine that this is A and this is B, okay, there's no way to say that you can somehow slide A around either horizontally or vertically so that you can get it to fit completely on B. You would actually need to do at least one other type of transformation. That's the only way it's going to work. So this is a point where that congruency doesn't work, right? Even if two shapes are always congruent, there's not a guarantee that you can translate one onto the other. However, if you start with a shape and do a translation, then the resulting shape has to be congruent. That one is true. So then if polygon A is an image of polygon B under a translation, then the polygons are congruent. True. If polygons A and B are congruent, then polygon A is the image of polygon B under a translation. False, because this is the example that proves it false. Even though they're congruent, they're not translations. Okay, that is all I wanted to say about translations. There's practice in the workbook. I'm sorry that this time I didn't pause. I had a hard time lining up what I was going to talk about in the Smart Notes with what's in the workbook. However, the stuff in the workbook you should be able to do fairly straightforwardly. Read the instructions closely, and yeah, I hope you have a relatively simple time working on the workbook stuff. And then until next time, thanks for listening, thanks for watching, have a great day.